All right, so here's 2006 Form B free response question number 6.
Hopefully practice doesn't go too late tonight.
2006 number 6 Form B.
Ours looks like 6:30 by the time.
All right. A car travels on a straight track during time interval 0 to 60. Car's velocity v measured in feet per second and acceleration a measured in feet per second or feet second squared are continuous functions. The table above shows selected values of these functions. Use appropriate units to explain the meaning of the integral from 30 to 60 of the absolute value of v of t of the car's motion. Approximate that using the trapezoidal method with 3 subintervals determined by the table. So let's start with the definition. We want to define this. All right, this is going to be the total distance in feet, right? Because the units.
The integral is the distance that the car travels from 30 to 60 seconds.
The total distance in feet, the total distance a car travels in feet. So total distance car travels in feet. From 30 seconds to 60 seconds.
The total distance in feet that the car travels from 30 to 60 seconds.
Yep. And it's that easy. That is the definition. Now they'd like us to do is to approximate this distance.
If you're to miss the part in feet, the units in that would be no points.
If you miss the feet, I don't know. Let's just not miss it. Yeah, because it said using appropriate units, explain the meaning. So if you lost the feet, they might not give it to you. Approximate 30 to 60 using the trapezoidal method. Okay, so we look at the table and let the table guide us, and they want 3 subintervals. So you see them? First, second, third subinterval. Now here's what you got to catch. They are not equal. They are not equal, and that's just life. All right, so I'm going to erase my definition. Give us some work room. All right. So trapezoidal method kind of looks like the midpoint method. So we write out our notation, 30 to 60 of v of t dt is going to be, all right. Well, trapezoidal method is always half because it's half base 1 plus base 2 times height. All right. So our base is this time, and again, 14 plus 10, and again, since it's the absolute value, we drop the signs, right? You drop the signs because you're using the absolute value. It's distance traveled. We don't care about the signs, right? So under the curve, from, and again, and the distance between is 5 plus 1/2, 10 plus 0. And the gap between these two is 15 plus 1/2. Got to check my table here. 0 to 10. And the distance in the last one is 10. All right. 24, 12 makes 60. Half of that is 5. 5 times 15 is 75. Half of 100 is 50, 110. How about 185? What's the units going to be? Yeah, feet, right on. So there we go. And we just did the trapezoidal method, and you have to show that work, otherwise it won't give you credit, okay? Now, part B. Part B, using approximate units, explain the meaning of the integral 0 to 30 of a sub t dt in terms of the car's motion. Find the exact value of 0 to 30 of a sub t. All right, so here I go. I'm going to erase this, give us space to work, and go back up so we can see the table. All right. And I'm going to save myself some writing. I think I'm just going to explain this. Use approximate to explain the meaning of the integral 0 to 30 a sub t dt. It's in feet per second squared. It's the area of the curve in feet per second squared over time t feet. It's going to be that. So what are you going to get? It's going to be the change in the car's velocity in feet per second from time 30, or time 0 to time 30.
It's just feet per second, isn't it? Not feet per second squared. Because the antiderivative of
Yep.
acceleration is.
It's a change in the car's velocity in feet per second from 0 to 30.
So the area under the curve in feet per second from 0 to 30.
Yeah, well, you want to say change in the car's velocity. Change in the car's velocity. Okay, you integrate a sub t, you're going to get the change in velocity from 0 to 30. All right?
Yeah. I got it.
Okay.
I said the area under the curve in feet per second from 0 to 30 seconds, which is the change in velocity. Right?
From time 0 to time 30. Yeah. Okay? And again, pause it here because I'm just going to take it and erase it right away. But that said, and it says find the value of that. All right, so listen, write this out. We're going to do the integral from 0 to 30 of at dt. What is the integral of at?
What is vt from 0 to 30?
It's vt from 0 to 30. So you evaluate this, so it's v of 30 minus v of 0, which might not be 0. So we go to our table, and I erase my marks. V of 30 is negative 14. V of 0 is negative 20, both in feet per second. So how about negative 14 minus a minus 20 feet per second? How about you do the math? Negative 14 plus 20, 6 feet per second. And that's the answers to B. We're done with B. All right? Letter C. From 0 to 60, there must be a time t when v of t equals negative 5. All right? Again, between two intervals, it's saying, hey, sometime the velocity has to be negative 5. They want you to justify your answer. All right. They said the function was continuous. So what are you thinking? I hope you're thinking intermediate value theorem. Right? If the function is continuous, I just have to come up to right here. At v of 35, so you just say, hey, v of 35 is negative 10. V of 50 equals 0. And it says it right here. It said it was continuous in the very first sentence, right?
Yeah,
So since v sub t is continuous, there must exist a value c, right? So that's all we got to do. By IVT, since v of t is continuous, and that has to be, right? Because it doesn't work with functions with discontinuities in it, okay? There has to exist a value, and because of this, right? That negative 5 is between 0 and 10. There exists some value c between 35 and 50, such that v of c equals negative 5 feet per second. All right? And again, I'm sure it looks like D is almost the same thing, but it's probably not going to be the intermediate value theorem looking at the problem. We've done the intermediate value theorem. What's the other theorem that's hanging out that we haven't talked about? Mean value theorem. And again, we'll see what it is. We don't want to jump off any bridges until we read the problem.
It has a sub t equals 0.
So for 0 to 60,
Which is v prime.
must there be a time t when a sub t equals 0?
And there isn't, is there?
Okay, well,
What do we have to say? Yes?
well, the answer is yes. Okay? Because what you want to do is look at the velocity. Okay, it's about the acceleration, but remember, we're going to use the mean value theorem here. And the mean value theorem, remember, states what? That the f prime of c is equal to f of b minus f of a over b minus a. But if you do this in terms of acceleration, you can say acceleration of c is equal to velocity at some b minus velocity at some a over b minus a, right? So we want to look at the velocities. And if the acceleration is supposed to be 0, are there two velocities in the table that are exactly the same?
Yes.
I guarantee the acceleration is 0 between 0 and 25 by mean value theorem. All right, and that's the only thing we got. All right, that's the only thing we got to write out. And so I would say mean value theorem, v of 0. Can you answer that, Cade? I'm trying to tape this. V25. Tell them I'll call them back. Tell them I'm taping myself. These two are equal. Since they are equal, A sub C, where C is between 0 and 25, all right, will equal 0. And you can prove it if you want to show it by doing this equation here, right? Because we have, was it negative 20 minus a minus 20 over 25 minus 0, which equals 0. All right? And then we're done. And it shows this. This is a point. Using the mean value theorem as a point. And you probably would want to write out a statement, but I'm not going to do that here. All right? And there is a point for the units on A and B. So the last point of this problem is they're going to go back and see, do you have feet on 185 and do you have feet per second on the 6? Okay? And that is the last problem on, the last non-calculated problem on Form B, 2006 AP Calc problem.